Hi, this is Mr. Max. So I'm doing some questions on probability. If you are in Namibia and you are using dy equals mx plus c to success book, find these questions on page 642. Now, the questions, there are three questions I'm doing, so it's about two different independence event. Um, So the very first question, should we go into it, it says that the probability that it rains on Monday is 3 over 5. So I have the 3 over here. So let me just go ahead and also add the information. So the probability that it rains on a Monday will be 3 over 5. So if you have to remember that when you go along down with the branch, you should always get an answer of 1. So in order for you to find this 2 over 5, you simply say 1 minus 3 over 5. That will give you this. So bottom line is here, they should add up to 1. Okay. Then the probability that it rains on a Tuesday, so that is Tuesday, it rains is 4 upon 7. So that it doesn't rain will be 3 over 7. Obviously, you need 3 to add to that 4 to make it a 1. Okay, and then the probability that rains on a, if it does not rain on a Monday, so we'll go to not rain on a Monday, the probability that it rains on a Tuesday, so this one over here becomes then 5 upon 7. Okay, so that then definitely means that if this one here is 5 over 7, then this one here will be 2 over 7. Okay, so we have actually completed that. So very important that you should remember, um, when you have downwards like this, it should add up to 1. It should add up to 1, and surely you can check that they are adding up to 1. Now, the question B, Roman 1 says, find the probability that it rains on both days. So the probability that it rains on both days, so you go to rain, so it's going to be the first fraction, which is 3 over 5, and if you're going along the branches like that, you multiply. So rain 3 over 5 times 4 over 7, so it's that combo out there times 4 over 7. Well, you can go ahead, multiply, that gives you 12 over 35. So remember, probability is always between 1 and 0, so you can give this answer as a decimal, but this should be fine. The second part says the probability that it rains, on Monday. So we already know what Monday's probability is. Monday is 3 over 5. Just go back and refer to the diagram. Monday, 3 over 5. It rains on Monday, but not on Tuesday. So that means when we go back to our diagram, so it's going to be 3 over 5 going in this direction times 3 over 7. So multiply that times 3 over 7. Okay, of course, numerator times numerator, that's 9 upon 35. There's a third one, the probability that it rains. So find the probability that it rains rains on only one of the two. So I have written this, one of the two. So that means, well, there's a little bit of work here. There can be a combo. The combo here could be the probability that it rains on only one of the two could be, you have rain and then you have no rain. Okay, or no rain, and rain. That is the combination that you have to take. So rain, no rain, rain 3/5 times 3/7. Rain, no rain. So when we add the probabilities down the columns. So rain, no rain. So let me show you. So rain 3/5, no rain 3/7. This is what I have here. Then no rain, rain. So that means we go no rain, which is 2/5, and rain 5/7. So 2/5 times 5/7, 2/5. So that's 2/5. And what did we say? 2/5, 2/5, no rain, times 5/7, rain, 5/7. So it's just a matter of you grabbing your calculator and getting that answer. So I'm just going to write it under here. So the first fraction, that's 9/35, like what we see before, plus, so that's going to be 2/7, so 5's cancel. And then you grab your calculator, you just add, this is 19/35. Okay, right. Part C of the same question says, if it does not rain on Monday, so does not rain on Monday, remember, not rain on Monday, the fraction was 2/5, okay? And when it says does not rain on a Tuesday, so when it's not raining on a Tuesday, it was 2/7. So I'm just taking that part from the tree diagram that I have already in part A. So we can go back there just to show you. So it's 2/5 times 2/7. So that's Monday and Tuesday. And then the question continues to say the probability that it does not rain on Wednesday, 1/4. So I brought in Wednesday. So Wednesday, 1/4. It will be here, no rain. Okay. So the question says, the instruction says, calculate the probability that it rains on at least one of the 3 days. So there's a reason why we are going to do this. So first we are going to find, firstly, we're going to find the probability that it does not rain at all, okay, on the 3 days. That's the first thing we're going to get. So we're going to take 2/5. Remember I said if you go along the branches like this, then you simply multiply. Okay, once you do that multiplication, you're going to get nothing but, so that's going to give you 2 times 2, which is 4. So we can actually simplify that a little bit. So it will simplify to 1/35. Now we know the probability does not rain for those 3 days, but we are looking for at least one, okay, of the days that it will rain. So the probability that it rains on at least one of the 3 days. I'm just writing all of this information down. So that will be 1 minus 1/35. That is how you find that one. So you take the whole 35/35 for 1 minus the probability that it does not rain. So that gives us nothing but 34/35 as the final answer. Okay, please remember you can always go back and forth, pause the video just to make sure. Right, question 2, Claudia goes to school by bus. The probability that the bus is late is 0.1, so late will be 0.1 over there. And I know here along the branch it should add up to 1, so this is going to be 0.9. That's what you add there to give you 1. If the bus is late, so I'm coming here, the probability that Claudia is late for school is 0.8. So if that is 0.8, then this one over here should be 0.2 because that should give you 1 again. If the bus is not late, so I'm coming to the bottom here, the probability that Claudia is late, so not late and late, is 0.05. So you need to find what this one is. It's 0.95. Remember, you say 1 minus 0.05. That's how you get 0.95, for example. So you always remember that. Okay. So we have completed a tree diagram. So we can answer questions that follow from that. So the first one is calculate the probability that the bus is late. So the bus is late, and keyword there, Claudia is late, and is late. So the probability when the bus is late, obviously that's 0.1, and when she is also late, it's going to multiply with 0.8. So multiply by 0.8. So 2 places after the decimal point, that is just 0.08. Okay, that's the answer for that. Part C, calculate the probability that Claudio is late. So when Claudio is late, the probability that Claudia is late will be, of course, the one that we calculated before, 0.1 times 0.8, plus we are finding all the late, okay? So probability that she's late is 0.1 times 0.8, and then not late, 0.9 times 0.05. So that is we have to go along that branches. So coming here, 0.9 times 0.05, so 0.9. So well, if you were to calculate all of that, you're going to get 1 over 8 or 0.125 as an answer. Right, so the last one is just saying the school term lasts 56 days. On how many days will Claudia expect to be late? Since the probability that she's going to be late is 0.125, you simply go ahead and multiply that by the 56. So you're going to have 7. So Claudia can be expected to be late for 7 days. All right, there's a third question. Sando and Bikila take part in a quiz. The probability that Sando thinks he knows the answer to any question is 0.6, as you can see. If Sando knows or thinks he knows, the probability that he is correct is 0.1 or 0.9 rather. So this is going to be 0.1. If that is 0.6, this one will be 0.4. So 1 minus that, okay? Otherwise, he guesses and the probability that he is correct is 0.2. So if that is 0.2, then this one here will be 0.8. Okay, you always have to add up to 1. Good. Now, we can actually answer the questions from there. It says, part B, find the probability that Sando thinks he knows the answer. So we have, he thinks he knows, and we have to multiply, and it's correct. So he thinks he knows. So when you go to thinks he knows, 0.6 there, 0.6, and it's correct. So 0.6 times 0.9. So that will be 0.6 times 0.9. So of course this is 0.54. The probability that he gets correct answer. So the only way this can happen, if we go back, is he knows the answer is correct. So our answer from part Roman 1, that answer plus, okay. So it's that answer plus. So let's go to correct. So there's another sort of a scenario or condition. So knows correct, then doesn't know, guesses 0.4, and then it gets correct. So 0.4 times 0.2 also. Okay, 0.4 times 0.2. So simply a matter of calculating all of that. So we know from our previous answer this one was 0.54. Then this one is 0.08. Simply add those two, then you get the answer. So here the answer will be 0.62. Good, let's bring in the other guy in. The probability that Bikila thinks he knows the answer to any question is 0.55, so I've brought in the tree diagram. Yeah. And if he knows the answer, he's always correct. So if that is 1 already, then remember this one here should be 0 because that should add up to 1. And if this is 0.55, then this one here should be 0.45. I hope you still remember how you calculate that one. Huh? Remember, you say 1 minus 0.55, and here is 1 minus 0. Then this last part says, otherwise he guesses, and the probability that he's correct is 0.2. So if that is the case here, then this one here should be 0.8. Okay, so we have completed that. Now it says find the probability that he gets the correct answer. So the probability that the guy gets correct, so let's just say gets correct answers, will be a combination of 0.55 times 1, because if you go around here, you have 0.55 things he knows, but then it gets correct times 1, so along there you multiply, because we are adding, consider also the other one, plus another one he guesses, which is 0.45, and then he gets correct 0.2. So basically all of that should give you the answer that we're looking for. So in this case 0.55 plus, in this case you're going to get 0.09. Okay, once you add all of that, you get 0.64. Good. So you can slightly see by comparison that Bikila is slightly better than that. So we are now told that the course is out of 100, so it's correct. We know already from our previous answer that Sando, when he gets everything correct, yeah, is 0.62. So we just simply take that 0.62 for Sando. So you'll be saying 0.62. Then you multiply by 100. Okay, so you have 62 correct answers. We do the same for Bikila. So let's see what he has correct. So it is this one, 0.64, and simply multiply 0.64 times the answer. So 0.64 times the answer, so that gives you 64 correct answers. Right, so that was a rather straightforward and a very short exercise. So do stand by. I'm going to do all the 3 diagram questions that are there, and just to make sure that you understand the concept, that you do not miss out on that. And I'm going to do all the 3 diagram, and then I'm going to do possibility space diagrams, but I've done it on this channel, so you can definitely check out the statistics. You'll see that I have done quite a number of questions with regard to this.